our mission, if you haven't heard me say this a billion times this semester by now, our mission is encouraging professionalism among tech enthusiasts in a collaborative fashion by facilitating learning beyond the scope of classrooms to develop innovative and inclusive ideas. It essentially means is bringing together a community of people who are interested in tech and collaborating, learning outside the scope of classrooms. So make sure you learn things that you normally wouldn't learn in classrooms, except for this meeting, because this meeting is specifically for things that you would learn in classroom. What is ACM at UC? Again, I've said this like 8 times by now in this semester, but with the students chapter for Association of Computer Machinery, we're essentially a group of people who are interested in computer science and programming and share that common interest. Most of our majors are CS, IT, computer engineering, IS, and electrical engineers, but you don't need to be one of these majors to be part of ACM. What do? We do events like social, professional, and technical talks. We have guest speakers and panels at general body meeting. We also do ICPC, which is a international programming contest, which we do in the spring semester. We do Revolution UC, which is probably the biggest thing that we do. Then we do socials and we do review sessions like today. Our services, we are active on Slack, Discord. We also record our meeting and our meeting minutes, and we also provide office hours. Code of conduct, essentially, just be nice to each other. Make sure that everyone has a friendly, inclusive environment. Next thing, Revolution UC, like I said before, is probably the biggest thing that we and it is coming back in spring 2022. So keep your calendars open and be sure that you check out our website and our social media on Twitter and Instagram to get more updates about Revolution UC. Next, we also have a Discord community. So we're kind of realizing that Slack is getting a little bit outdated, and Discord is where most people usually hang out these days. So if you're not on ACM's Discord yet, feel free to join using that QR code. So Python review session, which I'm guessing a lot of you are here for. We realized that CS students take one Python class in the fall semester, and the engineering education course also teaches Python, or like has Python in their curriculum. So we figured it'd be nice to do a review session to help all the people that need that help. And before we start the review session, we'll keep the review of Python on our end very minimal. So I'll quickly go through some concepts, which shouldn't take too much time. And then we're gonna keep it more audience focused, where you guys can ask questions from your classes or just any other doubts or queries that you have. And most students here are CS, and we also have a lot of upperclassmen, so it won't just be me. It would also be the rest of our exec and anyone else who needs help. So let's keep this collaborative and let's make sure that you're all active and asking questions before our finals. To start off, a little bit prerequisite. Hopefully you have Python 3 installed with idle, which is like the standard text editor that you get with Python, or just any IDE or text editor that you're comfortable with, where you can actually type out code, and hopefully some experience with Python, because we won't go in depth into the concepts of Python. It would just be a brief overview and then questions. So starting off, declaration of variables. Hopefully most people know this, and you can use this literally using like x equals 0, y equals 1, or hello world. And usually variables are divided into types. Although Python doesn't need you to define types, it is always good to know the type of a variable. So you can have integers, which would be -1, 1, 0. So it can range from negative something, whatever the Python ranges it to be, 64,000 something. But essentially negative numbers and positive numbers. Floats would be your decimal number. So when you have a number with point in it, so 2.5, 6.4, -3.2, all those would be floats. And strings would essentially be words. So something like hello world would be a string. And I can show you guys real quick on how to do that in Python itself. So if you can see over here, I have the Python shell open, and if I want to declare a variable, I can just use x equals 1. And if I type in x, it gives me the output of 1. And I can do the similar thing for a string, where I can write ACM, and when I input y, or like type in y, it gives me the string back. So easy enough, not too concept heavy yet. Next are input statements. So if you've ever used a computer, you probably know that you never have to declare a variable. So how does computer does all the things that it needs to? It usually takes inputs from the user, that is most of the case you, and in Python, we can do that using the input function. And before that, you need to mention the type of the input as well. And that's why it's always good to know the type of the variable that you want to use. Um, so over here, we can see x equals float, input, enter the value for the variable, comma x. What does this mean? So let's first start from the inside and move a little bit outside. Enter the value for variable x is within these quotations. So that's essentially the string that the user will see because you're asking the user to enter a value. And whatever message you want to give the user, you put it in this parent or like in this string value over here. Next is input. So this is something that you're telling Python, saying that, hey, I want an input for this particular variable, and this is the message that I want to send to the user before taking that input. So make sure you use this keyword input. And after that, you're mentioning float. And the reason you're doing that is because you want Python to know what kind of input you're taking. And in this case, it is a float. So you probably want a decimal number as an input. Similarly, you can do it for integer. And if you want a string, you don't need to use an integer, or like you don't need to use float or int. And the reason is that string automatically uses string as an input. And so therefore, if you want to use another type, you need to specify it. But if you're just inputting a string, you don't really need to specify it. Um, you don't really need to specify it to Python. Next is list of numerical values. If you want a list of numerical values, you can also use the eval function, which essentially eval stands for evaluate. So whatever the user inputs, it will evaluate it as a list. Next is output. So if you're going to input variables, you also need to output variables so that the user kind of knows what you've done or what difference you've made with those inputs. And the way you can do it mostly is with print. So if you use this, whenever you see this print statement, you're usually using it as an output. And another key thing to notice over here is format, which is format X. So within these parentheses over here, you can see that X will be replaced with whatever is in this parenthesis. So when we use X at 75.176, and you can use print the variable X equals 0 something something point 2f backslash n format X. So it's going to print out the variable X equals 75.18. And the reason it does 18 and not 176 is because of this point 2f that you see over here. And it's essentially just telling Python that, hey, I only want two decimal points, or like two numbers after the decimal point. So few formatting tricks that you can use using this format function and these curly braces inside your string. And if that's confusing so far, we can obviously go more in depth after in audience questions, because I understand this is a more complicated concept. But right now, I want to keep the review brief so that we have more time for questions. And the similar concept goes for integers and strings as well. Next is operators, which are divided into three called arithmetic operators, comparison operators, and logical operators. Arithmetic operators, as you can guess, are probably something where you need to use math. So something like addition, division, multiplication, division, power, which is x raised to y, modulus, which we won't go too much in depth right now, but essentially just remainders is for modulus. Comparison operators, when you want to compare two values, if you want to see something is equal to another value, if you want, or if you want to see something is greater or less than something, that's when you use comparison operators. And logical operators and or not, we'll cover that more in if-else cases, but essentially when you want to compare two comparison operators, if you want to see that, hey, is this value greater than that, and is this value equal to that, when you want to get more complicated with your comparison operators, that's when you will use logical operators. Um, One quick use logical operators or think about it is actually um, just say whatever you're comparing out loud, and usually that sentence itself makes sense and helps you kind of gauge what you're trying to accomplish. So condition statements, probably the backbone of computing, because there's no way you use a single line code where it does the exact same thing every single time. And if you want to add more pizzazz to your code, you'll probably be using if-else case. Um, so in Python, you can start off with an if condition one. And if that condition is true, which we saw in the previous slide, you'll probably use one of the comparison operators or logical operators as this condition. And if that condition is true, Python will execute whatever is within this block. And elif is basically just short for else if. So if this condition is false, it will check if condition 2 is true. And if condition 2 is true, it will execute whatever is within that block. And if that is false, it will check for condition 3 and so on. And if nothing is true, if all of these conditions fail, it'll go back to else case, which would be kind of like the default case that it goes back to. Next is loop. Loop can also get super complicated real fast if people don't have a very good understanding of it. And so think of loop as iteration. If there is one particular operation that you want to do over and over, you probably want to start using a loop in that case. If you want 10 variable inputs, you're obviously not going to type 10 things like 10 input lines. I mean, you could, but that's ideally not what you want to do. Because let's say it gets to 100 or 1,000, which it can a lot of times. You don't want to be typing that 1,000 times, right? And so that's why whenever you want something in iteration, something a lot of times, you want to think about using a loop. And there are two kinds of loops that you can use in Python. One is a for loop and one is a while loop. A for loop, while may make your life easier, can be a little hard to gauge at times. Spend some more time over here. So let's look at the syntax of for loop. It says for k in range n. What does that mean? So k can be any variable. It doesn't need to be something that you've defined before. K can literally be anything that you want it to be. And in range n is something that needs to be defined before and hopefully is an integer. And n is essentially the upper bound till when the for loop will run. And since you've not mentioned anything over here, the k will start from 0 and go all the way up till n. So think of it as this way. For k in range n will make k start from 1. Make k start from 0 and then go all the way up to n. So it will be k equals 0, k equals 1, k equals 2, all the way up to n. So that one single variable, which is k, changes every single time, and that's how you can make multiple different scenarios within a single loop. And when it comes to something like a list or a string, you can use a similar concept where you don't have to use range, but it can just iterate over a list. And I understand we've not gone over list so far. I know, I've seen that. I was just hoping for once we cover the review, before the audience question, we'll get food and done. But yeah, essentially, it'll just go over each and every single element in the list, and k will be the element in the list. So I can do a quick demo over here for loops. my computer isn't slow. I can make a list up with numbers 1, 3, 4, 5, and 7. And what I can do is do for k in L, oh, and I can print k and see what it prints out. It prints out 1, 3, 5, 1, 3, 4, 5, 7. So it essentially prints out each and every element in the list, and that's how you can go through a single list or any data structure like that. And when it comes to while loops, they're way less structured than a for loop. As you can see, for loops have a lot more rules, whereas while loop doesn't have as many rules. The only rule it has is while a condition is true, it'll keep on running. So think about it this way. While a variable is less than a certain value, it'll keep on running. And that means you as a programmer are in charge of changing that particular variable so that hopefully it breaks that condition at some point and gets out of the loop. Otherwise, you'll get into something called the infinite loop, which, as the name suggests, the program would keep running on infinitely because the computer doesn't know when to stop because you've not given it a condition to stop. So while you're working with while loops, the most important thing you need to be careful about is making sure you don't get into an infinite loop. And if you feel you're in an infinite loop, make sure you're changing that make sure that this particular condition does turn to false at some point in the program. Last is function. While functions in programming do look a little different, the essential idea is very similar to what you see in mathematics. If you've ever seen something like, oh, f of x equals x squared plus y, whatever, it's essentially that's exactly what you're doing. Is you have this function rectangle and it has two inputs, width and height. Now the idea should be that your function uses these inputs and outputs something. So when you do f of x equals x squared, if x is equal to 2, which is what your input is, your function should return something like 4 because 2 squared is 4. And over here, if you see, def rectangle, def is a keyword that you use to define a function so that Python knows that, hey, this is a function. And then you use width and height as two input parameters. And inside the function, you declare a variable called area, which is equal to width times height. And then you also declare another variable called perimeter, sorry, which is 2 times the width and 2 times the height. And then you can return both these variables together. And whenever you call this function, and calling a function is something that you'll hear a lot, and essentially just means that you're using that function right now. And whenever you do that, it should return a value called rectangle. And we'll go a little bit more in depth of what calling a function and returning a value looks like. But before we start off this example question, do you guys want to start getting pizzas? All right, sweet. So pizzas are in the bag, so the last row wants to start getting pizzas and then we can move a little bit forward.
We have cheese and pepperoni. We also have veggies. Please save that for the people who cannot eat pepperoni. Yeah, who want veggie, please.
Might have to borrow your laptop at some point. Because my computer is running low on batteries, and for some reason I cannot use my HDMI charging port at the same time.
Let me check this adapter because I only have USB-C.
I have a USB-C connector.
But like, wait, hold on.
So USB-C connector based on.
Okay, that's good. Yeah. Okay. Yeah, that'll work. Perfect. Let me know.
Where is our audience? I can do some demo. Like,
What?
they need to. I can do some demo if you want.
Okay, I mean, I was gonna literally make a like do an example function.
But when people like after the meeting, when people have questions, you can answer their question.
Yeah, I'm gonna do something like, what's wrong with this code? Like, or something.
Do you have something ready?
I have an idea, but I need to code it.
If you can do that real fast, you know, because if people don't have questions, then you can do that.
Yeah.
What's, do you know, are they like first year, second year?
I don't know. I do see some first year students,
There's
but I'm not entirely sure.
I had an idea, but I didn't get time to prepare.
Okay, that's fine. I mean, if you want to start preparing right now.
Or the office hours, like after the
We're gonna
meeting,
solve this
if people
like,
understand.
Also, if people don't have questions, I'm just gonna, if people don't have questions, I'm just gonna like, go through like a couple of concepts, at least just like a list or something like that, show some demos, and people still don't have questions, I'm fine it. We're going home. It's exam week. We're going to spend more time on meetings. Alright, if you have your demo ready, then we can do it. If not, you can wait for like half an hour or like done. Okay?
No, it was a what it was
Like you said that.
After.
They are messed up. Oh yeah, that happens. It's like they go a little. Yeah.
Thanks you guys. All right. Hopefully the pizza break was helpful because I know how important food is to this meeting, and I didn't want to keep you guys hanging till the last minute for food. So anyone who's still getting food, feel free to get more. But I'll go ahead and I'll go ahead and continue with the meeting. Um, so for this example question, let's read the question together, analyze it first before actually starting to code. Because that's one of the most important things when you actually start coding is making sure that you understand what the question is asking from you. Because if you don't understand that, coding is going to be 10 times harder. So let's look what it's asking for us. It's saying take a string input from the user and count the number of letters in it. The number of letters in it and not the numbers. And just for the sake of it, let's also assume that we don't want to count any special characters, just the 26 alphabets in English. So first thing I see is take a string input. I've learned about strings and I've learned about inputs, and I know how to do that. The user over here is again just us, and so there's not much to do with it. And next is counting the number of letters in it. So I see counting the number, and I know when it says counting the number means I have to keep a count of some kind of integer, because when I see numbers, I think of integers. And when I see letters, I think of strings. So I need to keep all of these things in mind before starting to code. Now, let's not think about counting the numbers of letters first. Let's just think about taking a string input. So I'll go ahead in my idle, and since I don't want to use idle, I actually want to create a Python file. I use the file option and make a new file. And all I see over here is take a string input. So when I take an input, I know I need to first declare a variable. So I'll call that variable user input equals. Now I remember the functions that we've learned before for input and output. So I can go back to them and look, all right, I need to input a string and all I have to do is input, enter the month you were born in or whatever message I want to give. So you can use input, please enter a string. Sweet. Let's save this somewhere. I honestly don't care where it saves. All right. So I can go ahead and at least run this first. I know this isn't the entire code, but for the sake of testing and making sure I don't get ahead of myself, we can try every bit of code real fast. So if you see over here, it says please enter a string, and I can do A, B, C, and that's it. It didn't do anything, but that's because I didn't ask it to do anything. Now I'm going to format this a little bit so that it looks a little prettier. And over here, I can print this so that I know it actually is doing something and test it again. And I can do ACM, ACM rocks. Sweet. And then it prints ACM rocks. So we know that that part works, and we know that we are able to take the input in. So if I go back to my question again, I know that I'm pretty much solid with taking the string input from the user. Now I have to worry about counting the number of letters in it, and not numbers. So let's not think about the number of letters in it. Let's just think about how many things or how many characters are in it. So let's just focus on counting the numbers first. Now, first thing over here, I don't know how many letters are going to be in it, and that's what I'm supposed to count. So how do I start off with that? I know that I need an integer, so I'll start integer or like declare an integer called count. And since so far I have nothing that I started counting, I'll declare it as 0. Next thing, I know to count something, I have to look at each and every character and go, all right, character number 1, character number 2, character number 3. That means I'm doing something over and over again. And that means I need to use a, come on, you guys know this, we've been over this. Yes, it could be a while loop or it could be a for loop, but essentially it needs to be a loop because I'm doing something over and over again. So first sake of a little bit of easiness and just for demonstration, I'll use a for loop for this time, but you can still do this exact same question using a for loop or using a while loop, sorry. So for, I need to just call it a variable. So I'll call it ch, which is usually short for character, but it could be anything that you want. In user input, because that's the string that I want to iterate over. For essentially the way I read this would be for each character in user input, do whatever I've mentioned after this. And what I want to do is count equals count plus 1. Now, why am I doing count equals count plus 1? The reason I'm doing that is when I know there's a character in it, I want to add a value to the count number. So when I see the first letter in user input, I want to increase count to 1. When I see the second value in the user input, I want to increase count to 2. That means every time I'm adding 1 to it, and that's why I use plus 1 over here. And I think that's about it. I don't think I want to do anything else in this for loop right now. So I'm just going to go ahead and print count to see what the value will be. And I'll run it again. And this time I do ACM rocks again. So it prints out ACM rocks and it prints out 9. Let's see if it actually has 9 values. So ACM, 3 values, and rocks is 5 letters. 3 plus 5 is 8, and it still inputs 9. Any guesses what that is?
The space counts as a character.
Exactly. The space in here also counts as a character because it's a computer. It doesn't know the difference between M or a space or an R. So it counts every single thing in it as one character. And as you can see before from our question, now I can count the number of things in it, but I only want to count the letters in it. So I want to count the letters in it and not the numbers. And that means I'll only want to increase the count for a certain condition. And that means I need to use
If statement.
yeah, thanks Daniel. What a smart kid. Uh, if we could have, we would have given you a $10 Amazon gift card if we had it in our budget. But yeah, essentially we need to use an if else case because we only want to increment the count for a certain condition. And so what I can do is if now I don't know how to check if it's a letter or not. If it is a letter, I'm guessing it needs to be within the range of A to Z, right? And so what I can do is if a letter is greater than A, so I can do if CH is greater than A. Exactly. Thank you. It needs to be greater than equal to. I was gonna test you guys on it later. What? No, that's okay. You gave the right answer. You'd also get a $10 Amazon gift card if you had one. And so if character is greater than equal to A, and if a character is less than equal to Z. So you can see all the concepts that we learned before with logical operators and conditional operators, how they usually work together. Because usually don't, or like it doesn't always happen, but most of the times you want to use multiple conditions at the same time. And that's when logical operators come in and kind of help you use those multiple conditions together. And so if character is greater than A and less than C, I want to use count, I want to increment count. And so this way, hopefully, if it all goes right, I I don't have to worry about the space that we had in between. One formatting thing though is for Python. It doesn't use brackets if you used any other programming language before. You might have noticed this is a very scripted language, and so you kind of need to make sure that everything within a block is indented. And the reason is that Python needs to know what essentially is within this block. It needs to know that I only want to do count equals count plus 1 and not print count. And that's why the indentations are kind of a way for Python to know that, hey, this is what a certain block consists and this is not what a certain block consists. So we have this code ready. I don't know if this is going to run, but the only way for me to know is actually run it and see what it looks like. So I can again do ACM rocks, but this time it only gives me 4, which is sus. Now, well, it is. I think it's okay. I think it's okay to bring it into ACM lingo, but I can see that I have OCKS as lower as lower what's it called? Lowercase, yes, thank you. As lowercase alphabets over here, but everything else is uppercase. So I know that these 4 things are over here, which is probably what it's counting. I cannot be sure about that, but that's what my best guess is right now. And the reason for that is I'm only considering the lowercase alphabets over here. So now there are 2 things that I can do is I can either make it complicated and include uppercase.
So when you use the if command, do you not have to have an else?
Yes, that's a good point. Having an else condition isn't necessary. It's always good to have it so that in case a condition fails at some point, you know where the problem is. But else case for Python isn't necessary. You can literally just have a simple if case, and that should be it. But good question. Mm-hmm. It's not super helpful, but it can definitely save you those extra 2 minutes during your ENET exams. Mm-hmm. All right. So I can either add a complicated another condition over here where CH is greater than equal to um, A and CH is less than equal to Z. Now another question that comes up is I have this condition over here as one, and I have another condition over here as another. Now, what should I add between these two? I've learned three logical operators so far, which is and, or, and not. We've seen and in action, but we haven't seen or in action. And so I'll spend another minute over here to kind of explain what this means. Now, this is a very long statement, so don't freak out. But essentially, think of it as if the characters between A and Z or lowercase a and z, or it is between uppercase a and z. Now, the reason we use or over here is because we want to include both of these conditions and not exclude them. So whenever you think of or, think of it as you're including more conditions into it or more possibilities into it. And whenever you think of and, it means you're limiting the number of possibilities a certain condition can have. And since we want to expand our range, we're going to use or between these two. And you don't essentially, I guess you do need brackets. And the reason I'm adding these parentheses over here is that it's more clear to Python which two conditions are joined by and which two conditions are joined by or. Any questions on this?
Are these being essentially compared with their ASCII values, or like how does it know minimum is the lowest number, alphabet is A, the highest is Z?
Good question. It does use ASCII values as you've mentioned before, and while it isn't a super complicated concept, for now we'll just assume that Python keeps a list of all the letters A, B, C, D, and it knows that like A comes before B and B comes before C. How it knows that isn't what I want to focus in this question, but that is a good point. Is Python inherently Python has a way of knowing that A and Z are A and Z or like A, B, C, and D, they all line up one after another. So we can go ahead and run this again and use our next or use our input that we've been for a while, ACM rocks. Now it gives A, which I think is the correct answer, and that's all what we've wanted. But let's try it again just to make sure we're not missing something. So one important thing is testing is a huge component when it comes to programming. So we're going to make sure that your program works not just for one case, but all the different cases. So let's do ACM 1, 2, 3 and gives 3 because ACM is just 3 letters and it doesn't include numbers in it. We can try some other special character again. You can do ACM 1, 2, 3 space modulus we love Baru. That's way too many characters for me to count, but 13 sounds like a right number to me, not gonna lie. Also, we can count. ACM is 3, B is 2, 5, 5 plus 8, 13. Exactly. Sweet. So we know our program works, and we know exactly not just what the answer is, but how to reach to the answer, which is more important in programming than getting or at least in your exams, it'd be more important for you to know how to get to the question than actually the answer itself. So since we've gone over example questions and covered a lot of topics in it, we wanted to ask you guys if you have any questions, either for exams or from your previous homeworks, or just any Python questions in general, things that you've been curious about. This is your time to shine. Oh, good question. Good idea. I know there was someone on Teams before. Yeah, there was one person on it earlier. By rough show of hands, can I see how many people are in ENED? Or if you're taking ENED right now, and anyone who's here from Python programming class, that's sophomores take. Oh, sweet. Wait, are you in both ENED and Python? Oh, sweet. So do you guys have questions from Fred's Python class, which I know is a lot more complicated than what we've been over here. But this is open to all and every classes. It isn't specifically for ENED. No questions? If not, if you guys don't have any questions, we can still hang around after it for a while if you don't want to speak out in YouTube. Oh, sweet. Sorry.
Can you explain how the return function works?
Oh yeah, good idea. I completely skipped over that. But we can just use this example that we have over here and kind of see how we can make a function out of this. So first thing I remember of making a function is the def keyword, which essentially just lets Python know that, hey, this is a function. And I can say count letters. One thing, it isn't necessarily something that Python cares about, but something you as a programmer should care about is naming your variables and your functions something useful, something that makes sense. It's always easy to see, or like most of the times you'll see examples, variables named just X or Y or I or J. But when you're actually programming, it's important to name your variable something that actually makes sense to you and that something that would make sense to someone who's reviewing your code. So I'm going to call this count letters. And for now, I will have no inputs or no values inside the parentheses. And essentially what I can do is just, I don't want to copy this. I'll just manually tab all of this in it for now. And which isn't super fun or super pizzazz, but it doesn't take too long. So I can just tab all of this. But as you can see, this function is still missing a return statement, but I'll just let it run as it is and see what happens. So I've named the function count letters, and that's what I'm going to call count letters. And when I do that, it still asks me for a string. I'm going to call it ACM12. And it prints ACM123. So it still works like we want it to. But what was the point of us using a function? Well, if we use a function, we can delete this print statement. And what we can do instead is to return count. Now let's see what this does. I can again do count letters. And it says enter a string ACM12. And it still does ACM12 and it returns number of letters in it, which is 3. Well, it still does the exact same thing. So I don't get why we need to use a function. Well, here's why we need to use a function. When this happens, what I can do is I can just call another variable is number of letters, and I can declare that value and do count letters. I don't know exactly if this will work because we're still using inputs, but let's see. I'm not entirely sure. ACM12, and this time it did not print 3. Do you see that difference? Where did that 3 go? Well, according to Python, we stored that 3 inside this variable. So number of letters has 3 in it. So when you want to store a value from a function, that's when you use a return statement because it essentially is returning it. It's using it as an output and throwing it to whatever you wanted to throw it at. So in this case, we threw it at number of letters. And like the variable number of letters, and so the variable number of letters will forever store that value till you obviously close the idle. Now another thing you can do is use your arguments or something, whatever variables inside the parentheses. So I can get rid of this statement over here and use user input inside the function. And let's see if this still works. So now what I can do is use number of letters equal to count letters. So now over here, this is something that a normal user would not know, but since you've programmed this, you might have an upper edge, or like you should have an upper edge, is making sure that the input actually is in strings, because Python now does not know, since Python usually whenever you use an input function knows that it's string, but in this case it does not know the variable or like the type of it. So you need to make sure that you use strings in it, and you can do ACM rocks, and it again prints ACM rocks because we still have that in the function, but the value of number of letters should be 8 now. So it still works like we wanted to. It's just different ways of using it. But essentially, when you have a whole lot of things going on, you don't want just a single script for you. And the best way to break it up is using functions. So it's a great way to modularize your code a little bit more when you have so many things going on and you don't want it to run in a single way. So another benefit of it is also, let's make another function called test. And then this just prints, I'm in test, exclamation. If I run this, it literally does nothing, right? But if I just type out test in the script itself, I can choose which, it says I'm in test. So I can choose which function I want to run and which function I don't want to run. So using functions, you can also choose which part of the script you want to run and which part of the script you may or may not want to run. So that's another great way to use functions. Great question.
Can a function call a different function?
Can a function call a different function? Absolutely. Which is also something that you would end up doing a whole lot, because as we saw before, the function actually returns a value. So let's say within this test, instead of printing I am in a test, I actually want to print whatever count letters return. So I'm going to do number of letters inside it, and I'll use count letters. ACM is cool. But actually, I'm going to change that. I'm going to call it Purdue is cool, because apparently that's a theme for today. It's a Sherpa, come on. And I can get rid of this now. Instead of saying I'm in test, I'm just going to print number of letters. And then I can still call just test. But by calling one function, I can actually call two functions, because it's still the function test actually ends up calling count of letters. And this way, just by physically calling one function, I can end up calling both of these functions as well. Good question.
You don't have to do an example of this, but if I'm not mistaken, Python, you can pass a function to a function, right? Like as a parameter.
Oh yeah, you can. Which is not something the kids in ENET here need to know, but people in Fred's class do need to know function calling a function. And if you guys are interested in Python, you can do a bunch of cooler stuff as well, where we can declare a function inside a function. So within this function, I can call nested function and make it do a bunch of cool stuff. But we try to not go too much in depth about it, because it gets very complicated fast. But essentially, Python is super powerful when it comes to stuff like this. Brian, did you have a question? Oh, okay. All right. Well, it is 7:55. So if you guys don't have any questions, we'll hang around for a little bit while. I'm not the only one who needs to answer questions. We have a bunch of upperclassmen over here. People who are great at Python.
We'll have 3 TAs in here.
Exactly. We also have peer TAs from ENET. So one of them is Lena. Liz also TAs for it. And who's the third one? And Brian also TAs for it. Oh, so does Bob. We have four ENET TAs over here. So if you have any questions, this is the time to ask. Plus, you can always ask questions to Baru. What? Piyush was an ex-TA. He's not a TA anymore. He's left. Yeah, he's left that life behind him. But I'm gonna go ahead and end the meeting and the call. Oh wait, actually, before my computer dies real quick, please join our Slack, join our sibling organizations. If you have a cool idea, come talk to me for leading a talk. We have no more meetings left for the semester. Good luck on your exams. Hope you all do well and have a great winter break. And if you haven't yet, please sign up for attendance on acm@uc.org. We'll hang around for a while for more questions.